Hello, I'm Sebastian. Welcome to Nine Nar Trees podcast. Today, I will summarize and review the book. Electrical Engineering Without Prior Knowledge by Benjamin Spahic is designed as a fast, beginner-friendly on-ramp for readers who want to understand how electricity and basic circuits work without heavy math or academic prerequisites. Framed as a 7-day learning plan, the book aims to turn confusion about volts, amps, resistance, and power into practical intuition that you can apply to everyday electrical devices, simple projects, and further study. Instead of assuming you already know electronics vocabulary, it walks through core terms and shows how they connect, helping readers interpret common circuit symbols, identify typical components, and reason about what happens when you change a value in a circuit. The promise is not instant professional certification, but rapid orientation, enough foundational knowledge to follow technical conversations, read introductory schematics, and avoid common beginner mistakes. As an entry-level guide, it is positioned for self-learners who want structure, clear progression, and confidence-building explanations. I will give you key takeaways from this book. Firstly, building intuition for electricity, voltage, current, resistance, and power. A core focus of the book is helping beginners form a mental model of electricity before worrying about advanced formulas. It introduces voltage as electrical pressure, current as the flow of charge, and resistance as opposition to that flow, then ties these concepts together through the basic relationships commonly taught in introductory electronics. The practical value is that readers can start predicting outcomes, why a higher resistance reduces current, why a higher voltage can drive more current through the same load, and why power matters for heat and device ratings. The topic also emphasizes units and measurement, because confusion often starts with mixing volts, amps, ohms, and watts. By framing power as the rate of energy use, the reader can connect abstract ideas to real experiences such as a hot resistor, a dim light, or a drained battery. This foundation supports later topics like component selection and troubleshooting. The intended outcome is not only memorizing definitions, but being able to look at a simple circuit and explain what is happening and what could change if one parameter is adjusted. Secondly, reading and reasoning about basic circuits and schematics, many newcomers get stuck because electrical engineering feels like a language with unfamiliar symbols. The book addresses this by introducing common schematic conventions and the idea that a schematic is a functional map rather than a physical picture. Readers learn to identify typical elements such as power sources, switches, resistors, capacitors, and ground references, and to understand how series and parallel connections affect total resistance, current paths, and voltage drops. This topic builds the skill of circuit reasoning, tracing loops, spotting nodes, and predicting which components share the same current or the same voltage. It also clarifies why polarity matters in certain components and when it does not, helping readers avoid early wiring mistakes. By practicing how to interpret a diagram, a beginner can move from random trial and error to purposeful construction and diagnosis. The broader benefit is that this skill transfers directly to tutorials, datasheets, and beginner kits, where schematics are the standard way to communicate designs. The book's 7-day framing supports incremental learning, so each new symbol or rule reinforces the previous day's concepts. Thirdly, core components and what they do in real systems. A beginner-friendly electrical engineering guide typically succeeds when it turns parts into functions, and this book highlights the practical role of essential components. Resistors are presented as tools for limiting current, dividing voltage, and protecting sensitive parts. Capacitors are explained through charge storage and their behavior during charging and discharging, which helps readers understand smoothing, timing, and noise reduction. Inductors and coils are positioned as magnetic energy storage elements that influence changes in current, connecting to ideas used in filters and power conversion. Diodes are introduced as one-way valves for current, supporting rectification and protection, while transistors are framed as controllable switches or amplifiers that enable modern electronics. The topic also encourages attention to ratings and real-world constraints, tolerance, maximum power dissipation, voltage limits, and the importance of choosing the correct component for the job. By learning components through typical use cases, readers can better grasp why a circuit is designed a certain way, not just what parts it contains. This component literacy is crucial for moving from theoretical understanding to building simple, working prototypes. Fourthly, measurement, tools, and safety habits for beginners. Understanding electricity is inseparable from measuring it, and the book emphasizes basic tools and safe working practices. A central instrument is the multimeter, and the reader is guided toward using it to measure voltage, current, and resistance in a way that matches the underlying concepts. This includes learning where to place probes, when to measure in series versus parallel, and how to avoid common errors such as blowing a meter fuse by measuring current incorrectly. Safety is treated as a foundational habit, not an afterthought, including awareness of power sources, short circuits, heat, and the risks associated with mains electricity compared to low-voltage battery circuits. The topic encourages a disciplined workflow: power off before rewiring, verify polarities, start with higher measurement ranges, and confirm assumptions with a quick test. It also supports troubleshooting logic by showing how measurement can isolate faults, checking continuity, verifying supply voltage under load, and identifying unexpected voltage drops. For self-learners, these habits reduce frustration and prevent damaged components, making progress more reliable across the 7-day learning approach. Lastly, from basics to momentum, a 7-day learning path and next steps, the 7-day structure is positioned as a motivational framework that breaks a broad field into manageable daily goals. This topic centers on learning progression, starting with foundational concepts, then adding circuit rules, then component behavior, and finally applying knowledge through simple analysis and practical thinking. The value of a paced plan is that it sets expectations and prevents beginners from jumping straight into complex projects without understanding why things work. The book encourages readers to connect learning to everyday technology, reinforcing that electrical engineering is not magic but a set of understandable principles. It also implicitly points toward next steps once the basics feel stable, such as exploring digital logic, microcontrollers, signal processing fundamentals, or deeper circuit analysis. The intended outcome is confidence and direction. Readers should know what to learn next, what vocabulary to search for, and how to approach new circuits with a structured mindset. By the end of this arc, a newcomer can transition from passive consumption of tutorials to active problem solving, using first principles to interpret new designs and troubleshoot issues logically. In conclusion, this book is best suited for complete beginners, curious hobbyists, students considering a technical path, and non-engineers who regularly encounter electrical topics at work and want clarity without a heavy academic barrier. Readers who benefit most are those who feel overwhelmed by jargon and want a structured, short timeline that helps them build confidence quickly. The practical life value comes from developing intuition about how devices use energy, how to make sense of common electrical terms, and how to approach simple problems safely, whether that means understanding household power concepts at a high level, troubleshooting low-voltage gadgets, or starting a basic electronics hobby. Compared with many introductory textbooks, the 7-day framing and emphasis on fundamentals make the material feel approachable and action-oriented rather than exhaustive and theory-dense. It is worth buying if you want a guided starting point that organizes the essentials into a clear sequence, helping you avoid scattered learning across random online sources. As a gateway, it can save time, reduce frustration, and prepare you to choose more specialized books later with a stronger foundation and better questions. If you would like to support Benjamin Spahic, you can buy the book through the Amazon link I've provided in the podcast description. After reading the book, please let me know what you think and share your thoughts. See you around.